Example 4 for RC circuit under Kirchhoff Law. The question is, an RC circuit has a resistance of 10 ohms, a capacitance of 0.1 farad, and is connected in series with a 12-volt battery. Find A. An expression for the charge on the capacitor at any time t, B. The current in the circuit at any time t, and C. The charge and the current 0.5 seconds after the switch is closed. Given the equation for an RC circuit, R dq over dt plus q over c equals to ET, right? To solve this question, first we extract the given information, which is R, C, and ET, right? We write here, okay? We write R, C, and ET, right? Now we look at the given question. A resistance of 10 ohms, okay? This is R, right? So we can write here R equals to 10 ohms. Okay, this is the symbol for ohms, right? And then we have a capacitance of 0.1 farad. Okay, this is C. Okay, so we can write here C equals to 0.1 farad, right? And then 12-volt battery. Okay, this is ET. Okay, so we can write here ET equals to 12 volts, right? Find A. An expression for the charge on the capacitor at any time t. Okay, so we can write here A qt equals to question mark. Okay, we want to find q, which is charge at any time t, or in terms of t, right? And then B, the current in the circuit at any time t. Okay, so we can write here B it equals to question mark. I means current. Okay, at any time t means in terms of t, right? And then C, the charge and the current 0.5 seconds after the switch is closed. Okay, so we can write here C Q 0.5. Okay, means the charge 0.5 seconds after the switch is closed equals to question mark, and I 0.5 means the current 0.5 seconds after the switch is closed, right? From the given question here, there is no initial condition. Okay, if the initial condition is not given, so we assume when time equals to 0, the charge Q equals to 0. Okay, so we can write here when t equals to 0, the charge Q equals to 0 coulomb. Okay, coulomb means the unit for charge, okay, which is Q, right? And then we can use this initial condition to find the value of C after integration, right? After we extract all the given information, then we can solve this question. Okay, to solve the question, we start with the equation for an RC series circuit, which is given by R dq over dt plus q over c equals to ET. Okay, from here, we substitute the values of R, C, and ET into this formula, right? So after we substitute the values of R, C, and ET, we got this. Okay, we replace R equals to 10, we replace C equals to 0.1, and we replace ET equals to 12. Alright, and then Q over 0.1 here. Okay, after we simplify, we get this. Okay, 10 dq over dt plus, this is actually 1. Okay, 1 over 0.1 equals to 10. So we have plus 10q equals to 12. Alright, after that, to solve linear differential equation, we need to make coefficient of dq over dt equals to positive 1. So means that we need to dividing each term by 10. Okay, so after we dividing each term by 10, so we got this. Okay, dq over dt plus 10 divided by 10 equals to 1q equals to 12 divided by 10 equals to 1.2. Right? After we success make the coefficient of dq over dt equals to positive 1, then start from here, we can compare with the original differential equation, which is given by dy over dx plus bxy equals to qx. Right? When we compare, variable y here is similar to variable q, which is charge, and variable x is similar to variable t, which is time. Okay, under linear differential equation, we need to find integrating factor, which is if, and if is given by e to the power of integration of px dx. Okay, px means the coefficient of y. In this case, our px or pt is equals to 1, okay, which is coefficient of q. Alright, q here means 1q. Okay, so we can write if for this linear equation equals to e to the power of integration of 1 dt. 1 here means coefficient of q. Okay, because our px here is coefficient of y. Okay, so from here, our px, or in this case, our pt equals to 1. Okay, and we need to integrate with respect to time. Okay, and when we integrate 1 with respect to time, it is equals to t. Okay, when we integrate 1 with respect to t, it is equals to t. So we got if equals to e to the power of t. Right? After we find the integrating factor, we need to find the solution for q, which is charge. And we can refer with the general solution for original linear differential equation, which is given by y times if equals to integration of qx times if dx. Okay, in this case, variable y means variable q. Okay, so we can write the solution for this linear equation is given by variable y here, we replace by variable q, and then times if. Our if now equals to e to the power of t, and then equals to, and then we have integration sign here, and then qx. Okay, qx, when we compare, it is equals to 1.2. Okay, and then times if, and our if equals to e to the power of t, and then we integrate with respect to t. Right? On the left hand side here, there is no integration sign, so we no need to integrate. Okay, but on the right hand side here, there is integration sign, so we need to integrate. Okay, after integration, we still have q times e to the power of t on the left hand side, and then equals to, when we integrate 1.2 e to the power of t dt, we can move out constant 1.2 from integration sign. So after integration, we still have constant 1.2 in front here. And then we integrate e to the power of t dt, we got e to the power of t. Okay, and then since this is indefinite integral, so we must put plus c at the back. Okay, now we need to find the value of c. So how to find the value of c? Okay, before that, we can name as equation 1. Okay, so how to find the value of c? Okay, from this initial condition. Okay, when time equals to 0, and then we assume q or charge equals to 0 because there is no initial condition here. Okay, the initial condition is not given. So we just assume when time equals to 0, the charge also equals to 0. Okay, so we can use this initial condition to find the value of C after integration. Alright. Right, so from here, we use time equals to 0, Q equals to 0. We substitute into equation 1. Okay. So after we substitute, we got this. Okay. Q equals to 0. Okay, we substitute here. And 0 times any value still equals to 0. And then equals to 1.2 e to the power of 0. And then plus C. After that, e to the power of 0 equals to 1. Okay, so after we simplify, we got this. Okay, 0 equals to 1.2 times 1 equals to 1.2 and then plus C. Okay, so from here we can solve for C. So we got C equals to negative 1.2. Okay, then we can substitute the value of C into equation 1 here. So after we substitute, we got this. Q times e to the power of t equals to 1.2 e to the power of t and then minus 1 over 2. Right? Right, now we want to find an expression for the charge on the capacitor at any time t. Right? So to find the charge at any time t means we need to write Q as a subject. Okay, to write Q as a subject, so we need to dividing each term by e to the power of t. Okay, so after we dividing each term by e to the power of t, so we got this. Okay, we can simplify e to the power of t in numerator and denominator here. So we got Q and then in bracket T here means Q in terms of T, which is time, and then equals to, we can simplify e to the power of t in numerator and denominator. So we got 1.2 and then minus. From here, we can use the properties of indices. So we can move up e to the power of t here. So after we move up, we got negative 1.2 times e to the power of negative t. Okay, this is the charge at any time t, means Q in terms of variable t, right? Alright, B, we want to find the current in the circuit at any time t. Okay, to find the current under RC circuit, we need to differentiate the charge with respect to time. Okay, and the current is I. Okay, the current at any time t means I t. Okay, equals to, we differentiate Q with respect to time. Okay, so we differentiate this. Okay, after we differentiate this, we got this. Okay, differentiate constant 1.2, we got 0, and then minus 1.2, and then differentiate e to the power of negative t, we got negative e to the power of negative t. Okay, after that we simplify. Okay, so we got it equals to negative 1.2 times negative sign here, so we got positive 1.2 and then e to the power of negative t. Okay, this is the current at any time t. Okay, we differentiate from the charge with respect to time, right? Under RC circuit, to find the current, we need to differentiate the charge with respect to time, right? C, we want to find Q 0.5 and I 0.5. Okay, Q 0.5 means the charge 0.5 seconds after the switch is closed, and I 0.5 means the current 0.5 second after the switch is closed. Okay, alright, C 0.5 seconds after the switch is closed, Q 0.5. Okay, Q 0.5 means we replace T equals to 0.5 into QT here. Okay, so after we replace T equals to 0.5 into T here, so we got 1.2 minus 1.2 e to the power of negative 0.5. And using calculator, it is equals to 0.472. Okay, this is the charge 0.5 second after the switch is closed. Okay, and the unit for charge is coulomb, right? So we put coulomb here, right? After that, we want to find I 0.5. Okay, I 0.5 means we replace 0.5 into IT here, right? So after we replace 0.5 into T here, so it is equals to 1.2 e to the power of negative 0.5. And using calculator, it is equals to 0.7278. Okay, I 0.5 means the current 0.5 seconds after the switch is closed. And the unit for current is ampere, right? So these are the complete solution for this question, right? Got it? Coming up next, second order differential equation. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.